Hi friends, in this video, let us discuss about doubly linked list. So we have already learned about linked list, but those were singly linked list. We also have doubly linked list, which are like singly linked list, but here each node contains 3 fields, one data field and 2 link fields. That is a link to previous node prev and the data part data and a link to the next node next. In singly linked list, we had only 2 fields in a node, the data part and the next part. But here, the node refers to not only the next node, but also to the previous node. In C programming, the structure of a node in doubly linked list can be like this. The data can be of any type, int, char, float, double, etc. But here it is an example of integer data. The link parts will usually have pointers. The prev part will point to the previous node and the next part will point to the next node. And like singly linked list, in doubly linked list also, a head pointer points to the first node and the next part of last node points to null. And since we have a prev pointer also, the prev part of the first node will also point to null. Here is an example of a doubly linked list. We have 3 nodes here with data part and 2 links at addresses 1000, 2000 and 3000. And the elements here are 10, 20 and 30. And since this is a doubly linked list, we have links in forward as well as backward directions. And firstly, the prev part of first node and the next part of last node should point to null. Then the first node's next is pointing to the second node and the second node's prev is pointing to first node and its next is pointing to third node. And the third node's prev is pointing to the second node. So that is a doubly linked list we can see here. Now let us discuss the advantages of doubly linked list. Unlike singly linked list, we can have bidirectional navigation in doubly linked list. And also, some operations like deletion and insertion are easier since we can get the previous node easily without traversal. Now what is the main disadvantage of doubly linked list? Here, extra memory is needed for additional prev pointer. And the basic operations become expensive because we need to maintain 2 pointers for each operation. Now, let us see a sample program to create a doubly linked list with 3 nodes with data 10, 20 and 30 and display it in forward and backward directions. So first, create a structure for a node of this doubly linked list. Here, we have struct node star prev and it is used to refer to the previous node. That is, it will hold the address of the previous node. Next, we have integer type data to store the information. And then we have struct node star next and it is used to refer to the next node. That is, it will be holding the address of the next node. Now declare the pointers of type struct node, head, middle and last. So memory is allocated in the stack. Now we can use malloc function to allocate memory dynamically with the size of struct node. So write head equal to malloc of size of struct node. And memory will be allocated from the heap section and its address will be returned. Similarly, memory is allocated in heap for middle node and last node. Now we have the 3 nodes. Next, we need values in the nodes. So let us assign values 10, 20 and 30 to these nodes. So the values will be stored in the data part. So write head data equal to 10, middle data equal to 20 and last data equal to 30. So now we have the nodes with values. The next step is to link these nodes. That is, the linked list should be like head node, middle node, last node. So let us link it using the prev and next pointers. Firstly, the prev of first node should point to null. So set head prev equal to null. Next, connect head to middle. So write head next equal to middle. So 2000 will be stored in the next of head. Now let us handle the middle node. Its previous node should be head, so write middle prev equal to head. So 1000 will be stored here. And its next should point to last node. So write middle next equal to last. So 3000 will be stored in the next part of middle. And last node, its previous node is middle, so set last priv equal to middle, so 2000 will be stored here. And since this is the last node, its next should point to null. So write last next equal to null. Now we have our linked list with 3 nodes. So now let us print each node's data in the linked list. So to print each node's data, we have to traverse the linked list completely. And unlike simply linked list, we can traverse from the beginning to end as well as in the opposite direction. So first, let us see the forward traversal. So we are traversing from beginning to end, and we can identify the end easily since the last node's next will be null. So start from head and print the data, and repeat till we have node's next equal to null. So first, create a temporary pointer temp and assign the head node's address. Now we have a while loop, while temp not equal to null. So this loop will continue till temp becomes null. So print the data which is present in the temp node, which is head now. So it prints 10 and move temp to the next node. So now temp points to 2000. Now check the condition and it holds. So print the data at address 2000, which is 20. Now move temp to the next node. So now temp equal to 3000. And when we check the condition, it is still true. So print the data at address 3000, which is 30. Now move temp to the next node. And now temp equal to null since temp next equal to null. Now check the condition again and it fails. So control comes out of the loop and we got each node's data printed on the screen. Now let us see the backward traversal. And we are traversing from end to the beginning. So we will start from the last node and we will print the data of each node till we reach the first node. And we can easily identify the first node since its priv will be null. So start from the last and print the data, repeat till we have node's priv equal to null. So first, create a temporary pointer temp and assign the last node's address. Now we have a while loop while temp not equal to null. So similarly, this loop will continue till temp becomes null. So print the data which is present in temp node, which is last now. So it prints 30 and move temp to the previous node. So now temp points to 2000 and check the condition, it holds. So print the data at address 2000, which is 20. Now move temp to previous node. So now temp equal to 1000. Now check the condition, it still holds. So print the data at address 1000, which is 10. Now move temp to previous node. And now temp will be equal to null since temp priv equal to null. Now check the condition again, but it fails. So the control comes out of the loop. And we got each node's data printed in the reverse order. So that is how we can perform forward and reverse traversal in doubly linked list. Now let us discuss about the real-time applications of doubly linked list. So it can be used in undo-redo systems and the next and previous functions in music or video playlist, etc.